Welcome to the DIY Honda Garage channel. Be diagnostic trouble codes, DTCs, P0134 and P0154 in the 2011 to 2017 Honda Odyssey indicate a heater system malfunction in the air-fuel AF sensors located on different banks of the engine. Specifically, P0134 refers to the rear AF sensor, Bank 1, Sensor 1, while P0154 pertains to the front AF sensor, Bank 2, Sensor 1. These sensors play a crucial role in monitoring the air-fuel mixture to optimize combustion efficiency and emissions. They are typically positioned in the exhaust system, with the rear AF sensor located downstream and the front AF sensor situated upstream before the catalytic converter. The malfunction in these sensors may affect vehicle performance and increase emissions, making it essential to address these error codes through a systematic troubleshooting approach. Ensure that all freeze data and onboard snapshots are recorded before starting the troubleshooting process. The AF sensors are integral components in the vehicle's emissions control system, specifically responsible for monitoring the air-fuel mixture, which optimizes the engine's performance. The rear AF sensor, Bank 1, Sensor 1, is located downstream in the exhaust system, while the front AF sensor, Bank 2, Sensor 1, is placed upstream. These sensors provide essential feedback to the Powertrain Control Module, PCM, to ensure the combustion process is efficient, thereby minimizing harmful emissions. When either sensor malfunction occurs, it compromises the vehicle's ability to properly regulate the air-fuel ratio. This can lead to poor engine performance, a decrease in fuel efficiency, and increased emissions, which can result in the vehicle failing emissions tests. Understanding the exact locations and functions of these sensors is crucial for effective troubleshooting. Several factors can contribute to the malfunction indicated by DTC P0134 and P0154. A faulty AF sensor is one of the most common causes. These sensors can wear out or fail over time. Another possible cause is an open circuit or damaged wiring connecting the sensor to the PCM, Powertrain Control Module, which can interrupt the flow of data necessary for optimal operation. Additionally, a malfunctioning PCM itself can lead to erroneous readings and codes. Poor electrical connections or loose terminals are another critical point to inspect, as they can create intermittent failures. It is important to note that if DTCs P2251 and/or P2254 are also present, they must be addressed first, as these are related codes that can affect the sensors being evaluated. The symptoms associated with DTC P0134 and P0154 can significantly affect the vehicle's performance and driving experience. One of the primary indicators is the illumination of the check engine light, which alerts the driver to potential issues. Drivers may also experience poor fuel economy, leading to increased operational costs as the engine struggles to achieve optimal combustion. Moreover, the malfunctioning sensors can result in increased emissions, making the vehicle non-compliant with environmental regulations. Other effects include poor engine performance, which may manifest as sluggish acceleration or hesitation during operation. Rough idling can also occur, indicating that the engine is not receiving the correct air-fuel mixture, further confirming the need for immediate attention to these codes. The first step in troubleshooting DTC P0134 and P0154 involves setting up the vehicle for diagnostics. Begin by turning the ignition switch to the on second position, which powers the vehicle's electrical systems without starting the engine. Next, use the HDS Honda Diagnostics system to clear any existing DTCs stored in the system. This helps in determining if the issue is currently persistent or if it was an intermittent failure. After clearing the codes, start the engine and allow it to idle in either park, P, or neutral, N, for at least 1 minute. This idling period enables the engine to reach its normal operating conditions. Finally, check for any pending or confirmed DTCs using the HDS to see if DTC P0134 or P0154 reappears. In Step 2 of troubleshooting, you need to check whether DTC P0134 and or P0154 is indicated again after the engine idling test. If either code is present, it confirms a persistent issue with the AF sensor or associated wiring, and you should proceed to Step 5 for more detailed diagnostics. If no codes are indicated, it suggests that the system might be functioning correctly at that moment. However, it raises the possibility of intermittent failures. Hence, further inspection of electrical connections is warranted. Look for poor connections or loose terminals at the AF sensor, the PGM-FI, Programmed Fuel Injection Subrelay, and the PCM to ensure that all wiring and connectors are secure and functioning properly. Step 3 involves preparing the diagnostic setup for testing continuity. First, turn the ignition switch to the lock, 0 position, ensuring that all systems are completely powered down before proceeding. The next action is to use the HDS to jump the SCS service check connector line, a critical step that allows for bypassing the onboard diagnostic functions temporarily. This is essential when isolating specific components like the AF sensor for testing. After jumping the SCS line, disconnect the AF sensor's 6P connector carefully. Ensuring no damage occurs in this process is critical, as this sensor must be examined further in subsequent steps. In this step, you'll need to check for continuity between the PCM and A-factor sensor to diagnose the wiring condition. Start by disconnecting the PCM connector B, which consists of 49 terminals. This step isolates the PCM from the electrical system, ensuring that measurements taken do not reflect any interference from the PCM itself. Next, perform a continuity test between the PCM connector terminal B13 or B14 for bank 2 and the A-factor sensor, sensor 1, 6P connector terminal number 6. A multimeter can be used for this test. A reading of continuity indicates that the wiring is intact. If there is no continuity, this indicates a probable open circuit in the wiring that should be repaired before proceeding. Step 5 is crucial for determining the health of the wiring between the AF sensor and the PCM. If continuity was found during the previous test, you can confidently proceed to Step 10, signaling that the wiring does not have faults. In this case, reconnect the PCM connector B to continue your troubleshooting process. Conversely, if no continuity is observed, this indicates that there is damage or an open circuit in the wires that connect the PCM terminal to the AF sensor. Immediate action is required to repair this open circuit to restore proper function. Once repaired, ensure to conduct a follow-up check for troubleshooting verification in the final steps. Final repair verification is a key stage that ensures all work done has effectively addressed the issue. Begin by carefully reconnecting all connectors that were previously disconnected during the troubleshooting process. This includes the AF sensor and PCM connectors, ensuring secure and proper fitment. Next, use the HDS to clear any DTCs in the system, resetting the vehicle's diagnostic capability. After clearing, restart the engine and monitor it under normal operating conditions. Finally, check for any reappearance of the DTCs P0134 or P0154. If these codes don't return, the issue has likely been resolved. If they do return, further investigation or component replacement may be necessary. Preventive maintenance is essential in ensuring long-term vehicle performance and reliability, particularly concerning AF sensors. Regular inspections of the AF sensors can catch potential issues early, preventing future systemic failures. Checking wiring integrity can help identify any fraying or damage due to wear over time. It's also critical to keep connectors clean and secure to prevent any intermittent issues caused by dirt, moisture, or poor electrical connections. Scheduling periodic diagnostics can help in identifying DTCs before they escalate into more significant problems. This proactive approach will not only enhance the efficiency of the engine, but will also contribute to reduced emissions, ensuring compliance with environmental standards. In conclusion, understanding the functionality of AF sensors is essential for maintaining optimal engine performance and emissions control. The stepwise diagnostic process for DTC P0134 and P0154 is designed to isolate the issues effectively, ensuring that electrical and sensor integrity is thoroughly checked. Addressing these trouble codes not only restores vehicle efficiency, but also protects the environment by reducing harmful emissions. Regular preventive checks and timely maintenance are invaluable in preventing these malfunctions from recurring. Following this guide provides a clear pathway to diagnosing and repairing issues related to the AF sensors in the 2011 to 2017 Honda Odyssey, ultimately enhancing both driving comfort and vehicle longevity. Please like and subscribe to the channel. See you next time!